Hello boys and girls, a very good evening and welcome to yet another live session on your upcoming IBPS PU exam brought to you by TalentSprint. I hope all of you are in good health and you had spent a good amount of time over the weekend getting ready and enhancing your preparation for this highly competitive exam. And I also hope that today's live session will add more value to your preparation, because what we're going to discuss today is something that has been in demand for a long time, right? A lot of requests from participants like you to do a live session on this topic, and the topic that I'm referring to is allegations and mixtures. Now, as such, the weightage of this can be anything, right? It could be from 0 marks to 5 marks, right? I mean, it's not compulsory that we have a question from this topic in the exam, right? It is one of those word problems that is commonly referred to as word problems, right? One of those word problems that you may get. So it can carry a weight of 1 mark, or if it is a data interpretation question based on this concept, then it can be up to 5 marks. So you never know. But interesting topic, and I must tell you to go through those basic videos that we have covering the concepts around allegations and mixtures, right? I mean, you know, it's that topic where you mix 2 varieties of rice, or 2 mixtures of milk and water, or 2 mixtures of alcohol and water, and then get a new mixture and play with those proportions and quantities, etc., right? So get the basics right. As always, videos are available on the YouTube channel. Go through those videos, understand the concepts, and then I think it will be easy for you to solve these questions, right? And one more interesting technique here is that allegation rule, where you kind of write the 3 numbers in a particular fashion, right? Like, let's say you have a type 1 mixture or a type 1 element, a type 2 element, you mix them to get a mixture. So you write them in a triangular fashion, right? And then do cross differences to get the ratio. A very interesting technique, so you should learn about it, because I'm not going to discuss all these basics in the class today. I'll quickly take up a few questions and then just start solving it. But don't panic if you're unable to follow any of this. That could probably because you are not thorough with the concepts, right? So I repeat, go through the concept videos and then try and follow the questions that we're discussing here. So let me get started. The first question with the first question from this topic, which is I think let me start with a basic one, right? A simpler one to begin with, to set the context, and then we'll move on. So I have a bunch of questions. Let me choose the appropriate one. Yeah, here we go. The first question on your screens now. Look at it. What does it say? In an alloy, zinc and copper are in the ratio 1:2. In the second alloy, the same elements are in the ratio 2:3. In what ratio should these 2 alloys be mixed to form a new alloy in which the 2 elements are in the ratio 5:8? Right? So that's a very basic and typical allegations and mixtures question, right? I mean, we can have anything. Here we are talking about alloys of zinc and copper. At times we can have most commonly we have mixtures of milk and water. Sometimes you have only milk and only water. Sometimes it could be 2 different varieties of rice. This is the basic format. So you have 2 different items. Each one could be a mixture of 1 or more elements, 2 or more elements, which are again mixed together to form a new mixture. So the proportion or the ratio of the 2 elements in each of these 3 is given to us: type 1, type 2 and mixture. Now based on this, you need to identify in what quantity should these 2 be mixed. That's a basic concept from allegations. Now how do you solve it? I mean, there are, if you observe, you don't have to do all this drama in the exam, but there is type 1, there's an alloy which has got zinc and copper. In what ratio? 1:2. There's another alloy which has got the same elements, right? Which means zinc and copper. In what ratio? 2:3. So here we have got zinc and copper in the ratio of 2:3. You add these 2. When you add these 2, you get a new alloy. And that has got zinc and copper in what ratio? It has got the 2 elements in the ratio 5:8. So the question that comes up now is, in what ratio will you mix these 2? Q1 is to Q2 should be equal to what? What should be the quantities, or what should be the ratio of these 2 mixtures to get such a proportion, right? You had one mixture with 1:2, the other mixture with 2:3. The mixture of these 2 mixtures gave 5:8. So what should be the quantity ratio here for us to get 5:8 is the question. Now, if I go by allegation rule, I mean, there are different ways of solving it. You can just, let's say, try to balance the quantity of zinc overall to get the answer. For example, let's assume this is Q1 quantity is Q1, this quantity is Q2. So what will be Q1, what will be the total quantity? Q1 plus Q2. You getting it? We have taken quantity Q1 for type 1, quantity Q2 for type 2. The overall quantity is going to be Q1 plus Q2. Now all you can do is just write an equation balancing the quantity of zinc. See, if the total quantity of first mixture was Q1, how much is zinc here? See, the ratio of zinc to copper is 1:2. So can you say zinc is 1/3 of the total mixture? So I'm just balancing the weight of zinc, right? Try to balance the weight of zinc across. So how much will zinc be here? 1 part out of 1 plus 2, 3 parts into Q1. You're getting it? 1/3 of Q1 is zinc. If I have to take copper, I can say 2/3 of copper is zinc. 2/3 of copper, sorry, 2/3 of the quantity is copper. 1/3 of the quantity is zinc, 2/3 is copper. So this much is zinc in first mixture plus this plus, right? We are adding what? More zinc. How much zinc here? 2/5. 2 parts out of 2 plus 3, 5 parts from Q2. This gave us what? It gave us this ratio. Now how much is zinc here? 5 parts out of 13. 5 out of 13, right? There are 5 parts of zinc out of total 5 plus 8, 13. Out of how much? Q1 plus Q2. You getting it? 1 out of 3 is zinc, 2 out of 5 is zinc, and 5 out of 13 is zinc. So I'm just trying to balance that. Now you solve this equation, you will get what is Q1 is to Q2. Now the question is, why are we taking the quantity of zinc? Why can't we take copper? Doesn't matter. You take either zinc or you take copper. What is important is do it for the same item across. If you're taking zinc from type 1, take zinc from type 2, take zinc from mixture. If you're taking copper from type 1, then take copper from type 2 and copper from mixture. Right? You can't be taking zinc from type 1, copper from type 2 and make a mess there. So it should be balanced that way. Now, another important point is here we have been given ratios. Sometimes you're given concentrations in terms of percentages. Like he can say there's an alloy of zinc and copper where 33% is zinc. Another alloy of zinc and copper where let's say 60% is copper. So if 60% is copper, it's obvious that 40% is zinc. So you know that the first alloy has got 33% zinc, second alloy has got 40% zinc, and the mixture has got some more percentage. So if it is percentages, just balance with that percentages. 33% of Q1 plus 40% of Q2 is equal to whatever percentage of Q1 plus Q2. Solve that equation and get the answer. So the point I'm trying to make is the concentration of a particular element can be given in various formats. It can be given in terms of ratios, it can be given in terms of percentages, sometimes the actual quantities might be given. For example, you may say that one alloy of zinc has got 4 kgs of zinc. One alloy of zinc and copper has got 4 kgs of zinc. Another alloy has got 40% zinc. So what do? Instead of writing 1/3 of Q1, you directly write 4 kgs of zinc plus 40% of zinc in Q2 is equal to whatever percentage in 4 plus Q2 and solve it. Right? So it can be given in different forms. You just have to know how to write this equation. Now let's solve this one. What happens? What do we get here? Solve this. 1/3 of Q1 plus 2/5 of Q2 equals to 5/13 Q1 plus Q2. Now you'll have to solve this. So let's take the let's take the LCM here. So what happens? Anything that gets cancelled out? No. So solve for it. Now I think 15 is the LCM here. 15 is the LCM. What do we get? 3 goes 5 times. So 5 Q1 plus 5 goes 3 times, 6 Q2. You understand? 3 goes 5 times. So 5 into 1, 5 Q1. 5 goes 3 times. 3 into 2, 6 Q2 equals to 5/13 times of Q1 plus Q2. Now simplify it further. Now cross multiplication has to be done. Again, your numerical skills are important. 13 5s 65 Q1 plus 13 into 6 78 Q2 equals 5 15s is what? 75 Q1 plus 75 Q2. You getting it? 5 into 15 75 times Q1 plus 75 times Q2. Now solve for this. What happens? If you take Q1 this side, 75 Q1 minus 65 Q1 is 10 Q1 equals to 78 minus 75 Q2 is 3 Q2. Alright, 78 Q2 minus 75 Q2 is 3 Q2. So what do we want? We want Q1 is to Q2, right? In what ratio should these two alloys be mixed? In what ratio should they be mixed? Q1 is to Q2 or Q1 by Q2. What is Q1 by Q2? Look at this. What is Q1 by Q2? Q1 by Q2 comes out to be 3/10. 3/10. So option B is the answer. Option B is the answer to this question. Now, an important question. Does it really take so much time in the exam? No. I am doing it slow. Or I am explaining it to you, so it's taking longer. When you do, if you know the concept, then you just write the equation, right? You don't have to do all those 1 dabba plus second dabba equals to the third dabba. That's not required. Just play with those numbers. From the ratios, get the concentrations of zinc, Q1, Q2, Q1 plus Q2. Solve that equation, the answer is yours. Yeah? Now the same problem can also be solved either using concentrations of copper or using the alligation rule. So let me quickly solve this using alligation rule. It's more of, I'm kind of explaining the basics here, and then we will move on to the next question. So I'm now going to solve the same question where we got the answer as 3:10 using alligation rule. Now what is alligation rule? You don't have to do all this drama there, right? You can just forget about all this. I'm not saying this is wrong. This is correct, but there's a faster way of getting the answer. What do we do in alligation rule? Let me solve that using a different color. Alligation rule, simple. What alligation rule tells you is, again, either use only concentrations of zinc everywhere or concentrations of copper everywhere. Yeah. So let's go by concentrations of zinc only. Or maybe let's solve by concentrations of copper. We have already solved using concentrations of zinc. Let's solve using concentrations of copper. But alligation rule. So alligation rule says you first write the concentration from type 1. What's the concentration of copper? 2 out of 3. So 2 by 3. Then write the concentration from type 2. How much is it? 3 by 5. Don't write 3 by 2. 3 by 2 is the ratio itself. We want concentration of copper, proportion of copper. 3 parts out of 5 parts. Then write the concentration of copper in mixture. 8 out of 8 plus 5, 13. That's it. Now take the difference of 3 by 5 and 8 by 13. Write the value here. Is 2. Take the difference of 2 by 3 and 8 by 13. Write the value here. This itself is Q1 is to Q2. As simple as that. In fact, if you see, we are doing the same thing here also. In this whole equations that you've seen, ultimately the same thing happens. There's only a technique where you find it easier because you're just writing the numbers and not all those Q1, Q2 variables. And it doesn't look like an equation, so it looks simpler. But actually the same thing happens here. So you take the difference of 2 by 3 and 8 by 13, write it here. Take the difference of 3 by 5 and 8 by 13, write it here in place of Q1, and the answer is yours. You'll get the answer. So Q1 is to Q2 should be, let's say, 3 by 5 or 8 by 13 minus 3 by 5 is 2. This is going to be 2 by 3 minus 8 by 13. Understand? Difference of these two. So 8 by 13 minus 3 by 5. This is 2 by 3 minus 8 by 13. Again, work is involved in terms of solving that. Let me just get some space for me to try it out, because I have to prove it to you that the answer is 3:2. Either you do it this way or that way. Answer is 3:10. Sorry, not 3:2, 3:10. So let me solve it now. The red solution. We have seen the blue solution. Now let's see the red solution, or rather the brown solution. What do we do? Take the LCM. What is LCM? 3 and 15. 3 and 5. 65 is the LCM. So 13 goes 5 times. This is 40. 5 goes 13 times. 13 3s is 39. Is 2. What is LCM here? 3 and 13. The LCM is 39. So 3 goes 13 times. 13 2s is 26. 13 goes 3 times. 3 into 8 is 24. That's it. This is the ratio. Now simplified, what happens? 40 minus 39 is 1. 26 minus 24 is 2. So 1 by 65 is to 2 by 39. Again, both of these cancel out with 13, right? 13 into 5, 13 into 3. So the ratio is 1 by 5 is to 2 by 3. Again, cross multiply, what do we get? 3 into 1, 3. 2 into 5, 10. 3 is to 10. That's the answer. Option B. So what did you learn from this? Either use concentrations of zinc or use concentrations of copper, you're going to get the same answer. Either use equation or use the alligation rule, you're eventually going to get the same answer. Concentrations can be given either in terms of ratio or percentage or any other thing there. You just have to know how to use the numbers. Okay, so that's about the first question from alligations and mixtures. Let us now take some. So this is the basic stuff is done. Let's take some interesting varieties now, right? More varieties. So the next question is on your screens now. Try this out. Try this out. What does it say? There are two vessels A and B having quantities of milk and water. The ratio of quantities in vessel A and B is 13 is to 11, and both of them have equal quantities of milk. The quantity of water in vessel A and vessel B is 40 liters and 30 liters respectively. The mixture of both the vessels are poured into vessel C. Find the ratio of milk and water in vessel C. So what does it say? There are two vessels A and B having quantities of milk and water. So there are two vessels A and B, both have quantities of milk and water. The ratio of quantities of vessel A and B itself is 13 is to 11. And both of them have equal quantities of milk. So try and understand this. This is vessel A, let's assume. Don't do all this in the exam. Just trying to set the context. So vessel A and vessel B, both of them have got milk is to water, milk is to water, and milk is to water. Okay. The ratio of quantities in A and B itself is 13:11. So if this is 13 parts, this is 11 parts. So if the quantity of vessel A is 30 liters, that in vessel B is 11 liters. If this is 26 liters, then this would be 22 liters. If this is 130 liters, then this is going to be 110 liters, right? So that's the ratio. And both of them have equal quantities of milk. Both of them have equal quantities of milk. Meaning, for example, if you say this is MAWA, milk in, milk and water ratio in A, and this is milk and water ratio in B. The point he is making is MA is equal to MB. The milk, not the ratio actually, strictly speaking, but the quantity of milk in A is equal to the quantity of milk in B. You getting it? For example, let's assume milk is MA here, water is WA, milk is MB here, water is WB. MA is equal to MB. The quantity of milk in first one is equal to the quantity of milk in the second one. That's the other point known to us. Now the quantity of water in vessel A and vessel B is 40 liters and 30 liters respectively. This water here is 40 liters. This water here is 30 liters. We have been given the quantities of waters also. Water in A and water in B is 30 and 40 respectively. Okay. So 30 and 40 respectively. The mixtures of both vessels are poured into vessel C. So these two are added. When you add these two, you get another mixture. Vessel C basically. Whether you say these two are added or pouring both of them into vessel C, get this. So both of all this is poured in vessel C. So what will vessel C have? It will have MA plus MB is milk quantity and 70 is the water quantity. Yes or no? MA plus MB as the total milk and water is 70. Find the ratio of milk and water in vessel C. So what is M is to W is the question. Capital M is to capital W. Find the ratio of milk and water in vessel C. Now please note guys that whatever I have done so far is not to be done in the exam. I am only explaining the question to you pictorially. Right? You don't have to write all this. How would you solve it now? The quantity of water, total quantity of water is 70 liters, we know. Total quantity of milk is MA plus MB. And MA and MB are equal basically. Find the ratio of milk to water. Right? Now one verification that I would do in the exam immediately, it doesn't help in this particular case, but one verification I would do is, I know that the total quantity of water is 70 liters. The total quantity of water is 70 liters. So I would quickly go and check which of these options have got the ratio in such a way that it is a factor of 70. See, anything that you have here, option A says 2:5, meaning milk and water, the ratio is 2:5. So that water 5 has to be a factor of this 70. You getting it? It has to be a factor of 70. So is 5 a factor of 70? Yes. Possible answer. Option is possible. Is 7 a factor of 70? Yes. Is this 7 a factor of 70? Of course. And 5 and 5 again are factors of 70. So in this particular question, it is not helping me. The verification is not helping me, but this is a very smart solution. We have used this extensively in the topic of ages. Ages is all about ratios again, right? If you go through the videos of ages that we have on our YouTube channel, you would know that most of the questions can actually be solved just by looking at that ratio. I know that Ram's age is 42. He's asking us to find out the ratio of Ram's age is to Rakesh's age. Now whatever that number is there in given options, it has to be a factor of 42. You're getting it? Just verify that. And many a times you find that only one option satisfies. Mark that as the answer without doing the solution at all. But unfortunately in this case, all the options have got either 5 or 7, both of which are factors of 70, so it doesn't help. So how do you solve it? Again, whatever alligation rule can be used, or you can write down an equation in terms of water, quantity of water. Like how would you do? You will say, you can maybe write an equation for water, right? The quantity ratio is known to us, right? Here also the water total quantity is known to us. So maybe frame an equation in terms of water to solve it. But is there a smart way to get the answer? Is there a smarter way to get the answer? In my view, yes. There is a smarter way to get the answer. How do you do it? How do you do it without putting pen on paper? This understanding is important, but how do you solve it without putting pen on paper? See, try this. I know that the quantity of water in both the vessels A and B is 40 liters and 30 liters respectively. And I know that the quantity of milk is equal. The quantity of milk is equal. Yeah? How would you look at it? I know the solution. I'm trying to translate it into an explanation. I know what we have to do. I'm just trying to see how do I explain that to you guys. See, the point is, what do we do? Yeah, so the point is this, try and understand. There are 13 parts. The quantity of A is 13 parts. The quantity of B is 11 parts. You know that since milk is equal in both of them, meaning out of this 13 parts, some parts are for milk and remaining parts are for water. Out of these 11 parts, some parts are for milk, remaining parts are for water. Now we very well know that milk is equal in both of them. So the number of parts for milk here and the number of parts of milk here will be equal. The difference in these two, the difference in these two parts is only because of water. You're getting it? What's the difference in terms of number of parts? See, focus on the difference. What is the difference? You very well know that the difference between the two quantities is 10 liters. 40 minus 30. Actually, strictly speaking, the difference is, don't get confused that we are taking difference of only water. What is the difference here? NA plus 40 minus NB plus 30. How much is the difference, you tell me? How much is the difference? See, you know that MA and MB are equal. So MA and MB gets cancelled. Yes or no? We know that milk in first one and milk in second one are equal. So MA and MB gets cancelled. 40 minus 30, 10. 10 liters. The difference is 10 liters. But if I go by the ratio, what's the difference in these two? 2 parts. 13 parts minus 11 parts. So can I say this 10 liters is equivalent to 2 parts? Yes or no? There are 13 parts in vessel A. There are 11 parts in vessel B total. So the difference is 2 parts. So can you now conclude that each part, see, this is the whole idea, right? I should always try to figure out what is one part equivalent to. I now know that one part is equivalent to 5 liters. That's it. There ends the matter. The moment I know one part is equal to 5 liters, this 13 parts will be 65 liters. And this 11 parts will be 55 liters. Now try see. We know that out of this 65 liters, so 65 liters and 55 liters are the actual quantities. This is not the ratio. Now these are actual quantities. Out of 65, if you look at milk and water, water is 40 we know. So obviously remaining 25 is milk. Out of this 55, water is 30 we know. 30 liters water, 40 liters water. So obviously remaining 25 is milk. And our condition is also satisfied. See, milk and milk have to be equal. 25 and 25. Water is 30 and 40. Or 40 and 30 respectively. Now what he's asking us to find out is find the ratio of milk and water in the vessel C. So what happens when I find the ratio of milk and water? 25 plus 25, total milk is 25 plus 25, which is 50, and total water is 40 plus 30, which is 70. What should be the ratio? 5:7. And that's your answer. Option B is your answer. Are you getting it? A simple observation. What did we get here? The milk quantity was equal, the water quantity was known to us, 40 liters and 30 liters. It is obvious that if milk is equal in both of solutions, the difference in their weight will come only because of water. The difference of that water is 40 minus 30, 10 liters. But if I go by this number of parts, right, 13 parts of first vessel, 11 parts of second vessel, the difference is coming out to 2 parts. So I know that these 2 parts are equivalent to 10 liters, which means one part is 5 liters. That's it. The moment you know one part, I know that total quantity of first mixture is 65 liters, 13 into 5. Total quantity of second mixture is 55 liters, 11 to 5. We can easily find out how much is milk in each one of them, right? 40 is water here, so obviously balance 25 is milk. Out of 55 in the second one, 30 is water, so balance 25 is milk. Total milk is 25 plus 25, 50. Total water is 40 plus 30, 70. The ratio is 5:7. Option B. Alright? So, the point I'm trying to make is you don't really have to work on those equations, these observations in terms of quantity difference in terms of parts, etc. will lead you to the correct answer. Yeah. Okay, let's take up the next question. Here's the next one. Try and solve this. The ratio of zinc and copper in an alloy of 32 kg is 5:3. Some quantity of additional copper and zinc is added to the alloy, and the quantity of zinc added to the alloy is 6 kg less then the quantity of copper added to the alloy. Find the percentage of zinc in the new alloy if the total quantity of the final alloy is 42 kgs. Okay, looks like a long question, but almost all the details are given there. See, what does he say? The ratio of zinc and copper in an alloy. There is an alloy 32 kgs, right? In the zinc and copper ratios, zinc is to copper, the ratio is 5:3. So can you tell me how much is zinc and how much is copper? We have learned this in our basics of ratios, right? Total how many parts? 5 parts of zinc and 3 parts of copper, 8 parts. These 8 parts are equal to 32 kgs. Yes or no? The total of these 8 parts is 32 kgs. So each part will be equal to 4 kgs. Yes or no? If 8 parts are 32, each part is 4 kg. So how much will be zinc? 5 parts. 5 into 4, 20 kgs. How much is copper? 3 parts. Each part is 4 kg. So 3 into 4, 12 kgs is copper. So we know that 20 kgs is zinc, 12 kgs is copper. Total is 32 kgs. Alright, that part is sorted. And this is all mental calculation. You don't have to really put pen on paper for this, right? 8 parts divided by 32, or 32 divided by 8 parts. 20 and 12 kgs. Now he's saying some quantity of additional copper and zinc is added to the alloy. I already have 20 kgs of zinc, 12 kgs of copper. I'm adding more zinc. So let's say 20 plus some Z dash. And I have added, let's say 12 kgs of copper was already there. I have added C dash. What is he saying? The quantity of zinc that is added is 6 kg less than the quantity of copper that is added. The zinc Z dash is 6 kg less than copper C dash. Find the percentage of zinc in the new alloy if the total quantity of final alloy is 40 kg. Now this is interesting. I already had 32 kgs. We already had 32 kgs. After adding some more zinc and some more copper in whatever difference that is given there, the new quantity becomes 42 kgs. 32 kgs has turned out to be 42 kgs now. Yes or no? So how much more has been added? 10 kgs more has been added. That's my understanding, right? 32 was there. Only if I add 10 kgs, I'll get finally 42 kgs. So I now know that Z dash plus C dash is 10 kgs. And I also know that the zinc is 6 kg less than copper. Zinc is 6 kg less than copper. Now this is a very, very common equation that you may come across. I have added something new. Total of two values is 10. And also that one of those values is 6 less than the other value. How do you solve these equations? I mean, I can write equations. I can say Z dash plus C dash equal to 10. Then I can say Z dash is equal to C dash minus 6. So solve these equations now. If you solve these equations, what happens? I mean, this equation will give us C dash minus Z dash is equal to C dash minus Z dash is equal to 6 kgs. So there are two equations, equation 1 and equation 2. If I solve these two equations, what happens? Z dash minus Z dash get cancelled. 2C dash is equal to 10 plus 6, 16 kg, which implies C dash is equal to 8. If C dash is 8 kgs, obviously Z dash will be 2 kgs because total has to be 10, right? C dash plus Z dash is 10. So 8 plus 2 is 10. 8 minus 2 is 6. Both equations are satisfied. Yes or no? 8 plus 2, 10. 8 minus 2, 6. So I now know that the new quantity of copper that is added is 8 kgs. New quantity of zinc that is added is 2 kgs. So just do that calculation. What happens? 20 plus zinc is 2 kgs. This is 12 plus new copper is only 8 kgs. So what's the ratio? 22 is to 20. 22 is to 20 is the ratio. Final zinc and final copper. What is he asking us to find out? Find the percentage of zinc in the new alloy. I already have the ratio. He's asking us to get the percentage. What is the percentage of zinc? See, 22 is to 20 is actually 11 is to 10. 22 is to 20 is as good as 11 is to 10. What is the percentage of zinc? Zinc is 11 parts. Out of total, 11 plus 10, 21 parts into 100. That's how we'll get the percentage of zinc. So you don't look at all these steps and get confused. It's a simple problem. 32 kgs, you know individual values. We're adding new zinc and new copper. How much we do not know. But we know that total added is 10 kgs and the difference is 6 kgs. You solve those equations, you'll get the quantity of zinc that is added and quantity of copper that is added. That gave us 22 is to 10. 22 is to, or 11 is to 10 as the ratio. Zinc is 11. Final zinc is 11. And final copper is 10. He's asking us to get the percentage of zinc. What will be the percentage of zinc? 11 parts is the quantity of zinc. Out of total, 21 parts. 11 by 21 into 100. Now this obviously will be slightly more than 50%. 10.5 by 21 would be exactly 50%. This is more than that. So more than 50. I think C and D gets eliminated. It should be, if I have to do a more precise calculation, 0.5 by 21. Yeah, it should be another 2%. So 52.4, option A would be the answer. Option A would be the answer. Okay, now I am before I go to the next question, I want to explain you this whole idea of solving two equations, right? Without actually writing those two equations. What did we know here? We know that zinc and copper, the new zinc and new copper total quantity is 10 kgs, and zinc is 6 kgs less than copper. Zinc is 6 kgs less than copper. How would you solve it without writing on paper? Simple. X plus y is 10. Forget about zinc and copper. X and y together is 10. And x is 6 kg less than y, or y is 6 kg less than x, whatever that case may be. What you have to simply do is, out of 10, remove that 6 kgs. Basically, the difference is 6. Between the two values, the difference is 6. Forget about the 6. What is the balance? 4. You divide that 4 equally between x and y. Now, if 4 is equally divided between x and y, each will get 2. So, x is 2 and y is 2. But where will the 6 go? The 6 will go to the one which is supposed to be more. So let's say x is 6 kg less than y, it said, right? So add 6 to y. There are 2 and 2. Add 6 here, it becomes 8. So 1 is 2, the other is 8. That's it. 2 plus 8 is 10. 2 difference 8 is 6. Both equations are. It is very important. I mean, this is a common situation that you may come across many times in many types of questions. You should be able to solve those two equations quickly. Like for example, let's say, take another example. History marks and math marks. You're talking about scores in two subjects. The score in history and score in math adds up to 80. The difference of history and math is, let's say, 22. Random numbers. 80 and 22. Total of two values is 80. The difference of those two values is 22. So you can actually write h plus m equals to 80, h minus m equals to 22, then solve 2h equals to 102. All that drama can be done. But why? What's the simple logic? Forget about this 22. Remove that 22 from 80. So if you remove 22 from 80, how much do we get? 58. 22 minus 80 is 58. Let me keep it simple for the sake of understanding. Let's say 20. 80 is the total, difference is 20. You can do 22 also, but I don't want to make your life complex at this point in time. So total of history and math is 80, difference is 20. One is more than the other, which one we would know anyways. So difference is 20. How do you get the two values? From that 80, remove this 20 instantly. What is balance? 60. Divided 60 equally, each will get 30 and 30. And put this 20 on the one which is supposed to be more. So one is 30, the other would become 50. Simple. 30 plus 50 is 80. 30 difference 50 is 20. Both the equations are satisfied. Total has to be 80. Difference has to be 20. Got it. Now let's do it for 22. History and math total is 80. And let's say math, may you have scored 22 more than history. Simply forget about the 22. Take the balance 58, divide it equally. If you divide 58 equally, each one will get how much? 29. 29 each. That's it. One is 29, the other is also 29. Now put that 22 on the other one. So 29 plus 22. 51. That's it. 51 and 29 are the values. You can check it out. 51 plus 29 is 80. 51 minus 29 is 22. Very, very powerful meaning useful way of solving these two basic equations. Okay, so I would not have done all this, let me highlight, right, this part that we have done here, right? This is not required. This zinc and copper is 10, the difference is 6, 2C is 16. No, it is sheer waste of your time. This is not required. I would know one is 8, the other is 2. So that's it. Add 2 to zinc because it is less, add 8 to copper because it is supposed to be more. You get the ratio. And after that, one more step. 11 by 21 into 100. 52.4 will be the answer. I hope all of you have followed this. If not, go through the video once again. Very, very useful thing. Let's now move to the next question. Okay. Okay, try this now. On your screens. Got it? Okay, let's take this up. Here's the question. Two jars A and B. There are two jars A and B. Both contain 20% milk. Both contain 20% milk. So obviously 80% is water. The balance 80% is water. The quantity of jar A is 4 times the quantity of jar B. Both jar mixtures are mixed and they form a new mixture C. And 15 liters of water is added. The final ratio of water to milk is now 19:4. The final ratio of water to milk is 19:4. Find the initial quantity in liters of milk in jar B. Now let me again draw the picture to make it easier for you to follow, right? This is jar A, right? This is jar B. Both have got 20% milk, so obviously 80% water. Here also 20% milk, 80% water. The only thing is the quantity of jar is 4 times. This quantity, let's assume if it is Q, the quantity of jar A is 4Q. The quantity of jar A is 4 times the quantity of jar B. But remember, irrespective of the quantity, the ratio is 20% and 80% only. 20% milk, 80% water. Here also we have got 20% milk and 80% water. Now both jars are mixed. Both are added to get a new mixture C. Remember, the percentages will remain the same irrespective of the quantities. The new mixture will also have only 20% water because the same portions are getting added, right? The quantity will be 5Q. 4Q plus Q, it will be 5Q. The quantity will be 5Q. But first one had 20% milk, 80% water. Second one also had 20% milk, 80% water. Obviously, when you add these two, you will end up having only 20% milk and 80% water. For the larger quantity, 5Q. 4Q plus Q, 5Q. But then to this 15 liters of water is added. We are adding 15 liters of water. Okay. So now the question is the final ratio of water to milk is how much? The final ratio of water to milk is 19:4. In this, the water to milk ratio is 19:4. The water to milk ratio is 19:4. So what was the initial quantity of milk in jar B? How much was milk in jar B is the question. How would you solve it? What we have done so far is only understood the question. Jar A, jar B, 20% milk, 80% water in both of them. Quantity of jar A is 4 times the quantity of jar B. When you add, you get this, but we are adding 15 liters of water to it. Overall, in this, the ratio of water to milk is 19:4. The ratio of water to milk is 19:4. And then based on this data, something has to be evaluated. Initial quantity of milk in jar B. How would you do this? How will you do this? Tell me. How do you want to solve this? Very simple. See, this is the final quantity of milk and water and milk, right? So W by M is equal to 19/4. What I would do is simply write an equation here. So this 19:4 is the total quantity of water is to total quantity of milk. What will be the total quantity of water? See, always I had, let's assume if milk is X. See, 20:80 means what? The ratio is 1:4. Here also the ratio is 1:4. In the final also the ratio was 1:4. Meaning if milk is 1 part, water is 4 parts. If milk is 1 part, water is 4 parts. So if milk is X, water is 4X. So what is the total milk? X only. Remember, we are talking about concentration. Total milk is how much? X. Total water is how much? 4X. Plus extra 15 liters here. In this, let's assume that, you cannot take X and X for each of A, B and C. Let's assume in C, here, let's assume the milk is equal to X. Water will be equal to 4X. Because the ratio is 20:80, right? You see, 1:4. 20:80 is 1:4. That's what we've got here. X and 4X is 1:4. So finally, in this final mixture, how much is milk? X liters milk. 4X liters water plus 15 liters water. That is equal to 19:4. Solve for X now. That's it. Solve for X from this. Solve for X, what happens? So 19X equals to, cross multiply, 4 into 4, 16X plus 15, which implies 3X is 15, so X is equal to 5. So you know that milk was 5 liters and water was 20 liters. X is equal to 5, right? 5 liters milk, 4 into 5, 20 liters water. And plus extra 15 liters of water was added. That's it. I am only interested in finding out the total quantity of milk. The total quantity of milk in this is 5 liters. The total quantity of milk here is 5 liters. Now, understand. Same percentages was used for milk everywhere and also for water, 20, 20, 80, 80, etc. We know that don't look at this 1/4. only will confuse you. The point I'm trying to make is, so basically it's this 20% of 4Q plus 20% of Q is equal to 5 liters. Are you getting it? This 5 liters is what? 20% of 4Q plus 20% of Q. 20% of 4Q plus Q. So basically 5Q, 20% is 1 by 5, right? So 5Q equals to 25, or Q is equal to 5 liters. This Q is 5 liters. Or this 4Q is 20. Out of this 5 liters, 20% is milk. So what is 20% of 5? 1 liter. Option E, none of this has to be the answer. Confused? I know, because I'm not forming equations, it might be slightly confusing, but if you're clear with the concept and then apply this straight stuff. See, there's too much of writing that I'm doing there, but that's actually not required, right? It's all about understanding the question properly and playing with that one variable throughout, either milk or or water. Yeah. What is asking us to find the initial quantity in liters of milk in jar B. What did we do? See, finally we know the mixture C will have 20% milk and 80% water. So the ratio is X is to 4X. X is to 1 is to 4. Did I get something wrong here? 19X, this is 16X. Oh, I'm sorry. I think I made a mistake. Calculation error. Just hold on. My bad. These are wrong calculations. Of course, X and 4X is correct, but what are the actual values? See, we got 19X, 4 into 4, 16X, and 4 into 50, 60. This mistake I did. Sorry about this. 4 into 15 is 60. Yeah. So we got 3X equals to 60. So X is equal to 20. Yeah, this is 20 and this is 80. Okay, this also has to be redone. And that's how it would happen in the exam. One mistake, you will end up getting a wrong answer. I think what I got was, this is not the value. Q, this is not the value. I mean, it is Q and 4Q, but actual values would differ. Simple. You see, 5Q is 100. 20 plus 80, total quantity is how much? 100 liters. 5Q is 100 liters, so Q will be 20 liters. Yes or no? 5Q is 20 plus 80, 100 liters. So Q will be 20 liters. Out of this 20 liters, 20% is milk. 20% of 20 liters is 4 liters. Option B would be the answer. Yeah? We don't even have to do whatever equations we had done last time. Total quantity 5Q comes out to be how much? 20 plus 80, 100 liters. This is 100 liters. If 5Q is 100 liters, 1Q will be 20 liters. And milk out of this is only 20%. So 20% of 20 liters. 4 liters is the answer. Yeah, my bad. I made a mistake there in that equation. 19x equals to 16x plus 60. So 3x is 60 and x is 20. So the point I'm trying to make is, you can as well write equations to solve, but not really needed. Just get this concept thoroughly in your head and play with the given percentages or ratios there. Okay. Next question. This again is a standard question type. I would prefer using the formula to solve this question than... This is actually, if you go through our videos, right? This is Alligations and Mixtures Model 3. I mean, if you go through our basic videos on alligations and mixtures, we've got 4 model 1, 2, 3, 4. This is model 3. This whole question is based on model 3. And if you know that shortcut formula in model 3, you'll be able to solve this question in a few seconds, like 10 seconds or so. Let me read the question first. 6 liters are drawn from a cask full of wine and it is then filled with water. 6 liters of the mixture are drawn and the cask is again filled with water. The quantity of wine now left in the cask is to that of water in it is 121:23. Right? The quantity of wine now left in the cask to that of water in it is 121:23. How much does the cask hold? So basically there is a container, right? That container is full of wine. There's a big container, right? It is full of wine, right? Filled with wine. What do? We remove 6 liters out of it. 6 liters of wine is removed and 6 liters of water is added. Same quantity of water is added. So you remove 6 liters of wine and add 6 liters of water. So the moment you remove 6 liters of wine and add 6 liters of water, it now becomes a mixture. Till now it was pure wine. Now it's a mixture of wine and water. From this mixture, again 6 liters of the mixture is removed. The same process is repeated. 6 liters of mixture is drawn and 6 liters of water is added. The problem here is second time when you remove 6 liters, it won't just remove wine. It will also remove some water because it has already become a mixture of wine and water, right? This thing has already become a mixture of wine and water after the first removal and addition. So next time when you try and remove 6 liters of mixture, you won't get pure wine or pure water. You will get a mixture of wine and water. However, you remove that 6 liters of mixture of wine and water and add 6 liters of pure milk, pure water. Right? You'll add 6 liters of pure water. So overall, if you see, you have added 12 liters of water. 6 liters after first removal, 6 liters after second removal. But how much of wine have you removed? Have you removed 12 liters of wine? No. In the first step, you removed 6 liters of wine. In the second step, you will be removing less than 6 liters of wine because some water also would come out. So this is the transaction basically. This is what is happening there. This is the operation that has been done twice. He says finally the quantity of wine to water in this after these two transactions is 121:23. Finally the quantity of wine and water is 121:123. So how much is the overall capacity of this container? How much can the cask hold? How much quantity can this hold is the question. Now the formula goes like this. It's like, final so I would say final, let's say in this case it is wine, right? So final quantity of wine by initial quantity of wine. It's like a compounding process basically. Final quantity of wine by initial quantity of wine is equal to 1 minus B by total capacity. Let me change B also. Why do you use B? This sounds complex, but you have to learn it by heart to make your life simple. Quantity removed whole power n. If you learn this formula and you apply it, you will get the answer in straight one shot. Final quantity of wine in this container by the initial quantity of wine in this container is equal to 1 minus the quantity removed in each instance. Removed, this is not remaining, this is quantity removed. Quantity removed. How much quantity is being removed? 6 liters each time. We remove 6 liters first, then we have removed 6 liters again. And this formula is applicable only if you are removing the same quantity. Second time, instead of 6 liters, if you remove 8 liters, the formula would go for a toss. You'll have to do something else. So quantity removed divided by total capacity, which is what we have to find out, right? He's asking how much does the cask hold, the total capacity. We don't know. Whole power n. N is the number of operations. How many operations have you done here? Two operations. You have removed 6 liters how many times? Twice. If you remove it thrice, then n becomes 3. If you remove it 4 times, then n becomes 4. Now use this formula. Now this basically, see, we do not know the final quantity of wine versus initial quantity of wine, but what we know is the ratio. Actually, initial quantity of wine is not known. If you know the initial quantity of wine, that itself is the answer, right? This cask was full of wine initially. So either I know the capacity of cask or I know the total quantity of wine initially. Both are same. I would get the answer. But unfortunately, we do not know that. So how do you solve? Look at this ratio. He says the quantity of wine after doing these two operations, there is wine is to water, right? That ratio is 121:23. That ratio is 121:23. If you try and observe, one important point here is we are overall removing only 12 liters from this container and adding only 12 liters to this container. There is no change in the total quantity. The total quantity always remains the same. Initially, when I removed 6 liters of wine, I added 6 liters of water back to it. Then I removed 6 liters of mixture and again I added 6 liters of water. So the total quantity has not been tampered with. Total quantity remains the same. So what I can do from this ratio is final wine is to final water. Final quantity of wine is to final quantity of water. Wine is to water. What is wrong with this? Achha, both are W only. I'm wondering what went wrong. So let's say wine is to final water. What is the ratio? 121:23. 121 parts of wine, 23 parts of water. From this I can say that final wine ratio only by initial wine. The ratio. Final quantity of wine by initial quantity of wine can be taken as simply 121 divided by 121 plus 23. Because whatever is water here, 23 parts of water, originally was only wine, right? Whatever water has come inside this container has come because of removal of wine. So if these 23 parts of water were not there, we would have 23 parts of wine only. So finally there are 121 parts of wine, but initially there were 121 plus 23 parts of wine. These 23 parts became water after these transactions. That's how we get the ratio. So now use the formula. Final quantity by initial quantity ratio, I know 121 by 121 plus 23 is 144. That is equal to 1 minus 6 by, let's assume total capacity is T. That's what you have to find out, whole power 2. That's it. Now when you're solving this question in the exam, guys, you will not write all this. Let me just highlight. All this in red is not required. All this you're not going to put on paper. You're not even going to write the formula on paper. Smart students will just start with this step. 121 by 144 is equal to 1 minus 6 by T whole power 2. This is what you will start, and this is where you will end actually. Now what do? Apply square root on both the sides, because I have to deal with this square, right? Apply square root on both the sides. 121 by 144 becomes 11 by 12 equals to 1 minus 6 by T. So what happens? 6 by T is equal to 1 minus 11 by 12, which is 1 by 12, or T is equal to 6 into 12, 72. And that's your answer. Option D is your answer. If you have not followed this, don't panic. Go watch model number 3 from Alligations and Mixtures, which is available on our YouTube channel. Very easy and a common question. I mean, you can expect this. To make it complex, they may give 3 transactions or 4 transactions. So it becomes power 3, power 4. You have to take cubed root or fourth root accordingly. What is important here is to understand how to get that final ratio, initial by final or final by initial ratio, right? 121 is to 23 is the final ratio. But whatever is water now was originally wine only, because water came into that container only when wine was removed. So if this water were not there, it would have been wine. So final quantity of wine, if it is 121, initial quantity of wine was 121 plus 23. I mean, these are not actual quantities, these are in terms of a ratio. So 121 parts is wine, 23 parts is water. So final wine is 121 parts, initial wine is 121 parts plus those 23 parts. So 121 by 140. Okay, let's take the next one now. Okay, I think I have got one more question. Here we go. On your screens now. Got it? Let's take it up. An alloy of copper and aluminum has 40% copper. Another alloy of copper and zinc has copper and zinc in the ratio of 2:7. These two alloys are mixed in the ratio of 5:3. Quantity of aluminum is what percentage more or less in the quantity of copper in the final alloy? Now what is interesting about this question is that there are two different mixtures. In the first mixture we have copper and aluminum. In the second mixture we have got copper and zinc. I mean, I'm calling alloy as a mixture, means the same, right? So we have a mixture copper is to aluminum, right? Copper and aluminum. What is it? 40% copper. It's obvious that if 40% is copper, the balance 60% is aluminum. So it's as good as 2:3. you should straight away write 2:3. Don't waste your time in writing 40, 60, right? Copper and aluminium, the ratio is 2:3. There's another alloy of copper and zinc this time. This is first one. Right? What does the second one have? The second one has copper and zinc. Copper is to zinc. What's the ratio? I think this time straight ratio is given 2:7. So copper and aluminium 2:3. Copper and zinc 2:7. That's the ratio. So if it is like 2x, 3x, this will be 2y, 7y. Remember, you cannot take x for two different ratios. A very important point that I would like to highlight. Many students commit this mistake. So when they say 2:3, the general convention is to take 2x, 3x, 2x and 3x. Now when there is 2:7, don't take 2x and 7x again. Then you say total copper is 2 plus 2, 4x, total aluminium is 3x, total zinc is 7x, and that's the wrong solution. Because if you are considering x as a multiplier for one ratio, the same multiplier cannot be taken for another ratio. You have to use a different multiplier. Total quantities might be different, right? If the total quantities are same, 2:3, whatever the total amounts to, quantity in terms of quantity, and 2:7, if it amounts to the same value as 2:3, then you can straight away add or take the ratios. But you can take 2x, 3x, 2x and 7x. But when the quantities are different, if you're taking x as a multiplier for one ratio, do not take the same x as multiplier for the other ratio. There you have to take something else. So maybe 2y and 7y. Right? So keep that in mind when you are dealing with such questions. Are you guys able to see the screen? Yeah, I think I thought I came on the screen, but I didn't. Anyway, so the point is, if this is 2x and 3x, this is 2y and 7y. You can't take same multiplier. Now when these two alloys were mixed in the ratio 5:3. These two were mixed in what ratio? 5:3 ratio. 5/3. So 5 parts of this overall and 3 parts of this. The quantity of aluminium is what percentage more or less in the quantity of copper in the final alloy. See, final alloy, the final alloy that you get, final mixture that you get will have what? It will have copper, aluminium and zinc. There will be 3 elements. This one has only 2, this one has only 2, but the final one will have 3. Because copper is common there, there will be some copper, some aluminium and some zinc. We need to get this ratio. The whole solution is about getting this ratio right. If you get the ratio right, then you're done with it. He's asking aluminium here, finally, is what percentage more or less than copper. So once you know the ratio, you can play with those numbers to get the answer there. Yeah? So quantity of aluminium is what percentage more or less than the quantity of copper in the final alloy. Is it 11.1/2 percentage or 11.1/3 percentage or 12 percentage, 13 percentage, 12.5 percentage? How do you want to deal with it? Simple. To make it simple, since the final answer is only about percentage, I can assume that there is 500 kgs of first alloy and 300 kgs of second alloy. Let's assume there is 500 kgs of first alloy, 300 kgs of second alloy. 300 kgs of second alloy. See, what I'll simply do is, you cannot directly play with the ratios there, right? You cannot directly play with the ratio since the quantities are different. Overall, if I have to calculate the ratio, I can do something and get it here. But there are 5:3 in which they have been mixed. So you have to be careful about it. Now the challenge I see is, so what I'm going to do is I'll find out how much is copper in this 500 kgs. How much is copper in this 300 kgs? I'll write that value here. Is to, what is the aluminium in this? I'll write the value here. What is the zinc in this? I'll write the value here. I'll get the final ratio. But the challenge I see here is 2:3. 500 kgs can be divided in 2:3 ratio simply. 200 kgs and 300 kgs. But to divide 300 in the ratio of 2:7, it's going to be a little complex, right? I mean, 300 is not divisible by 9. 500 is divisible by 2 parts plus 3 parts, 5 parts, very easily. But 300 is not divisible by 2 plus 7, 9 parts. Yes or no? 270 and then there will be extra 30 and all that. So I want to take a value here which is divisible by 9. 2:7, right? 9 parts. 300 is not divisible by 9. But if I multiply this with 3, let's say 900 kgs, then is it divisible by 9? Yes, very easily. 900 kgs can be divided in the ratio of 2:7. But the problem is I simply cannot multiply this with 3. If I have multiplied this quantity with 3, the other quantity also should be multiplied with 3 so that the 5:3 ratio is maintained. If this 3 is not there, this is 500 kgs, this is 900 kgs. What's the ratio? 5:9. But I want the ratio to be 5:3. So to maintain the ratio, if you are multiplying this with 3, multiply the other one also with 3. 1500 kgs. See, final ratio remains same. 1500 is to 900 is still 5:3. No problem. 1500 is to 900. is 5:3 only, no problem. That's why we say, right, in a ratio, when you multiply both the parts with some value or divide both the parts with some value, it doesn't impact. You cannot add 300 kgs to this and 300 kgs to that. Addition will change the ratio. Subtraction will change the ratio, but multiplication and division would not change. So if I'm multiplying one value with 300, I'm doing the same thing with the other one also, 1500 to 900. Why am I doing this? Because now division becomes simple. Look at this. We want final copper is to final aluminum is to final zinc. How much is copper? 40%. Don't go by ratio. Let's say 40%. 40% of what? 1500. What is 40% of 1500? 600 kgs. Plus there is more copper. How much more? Copper is coming from second alloy as well, right? How much is that? See, I have to divide 900 in the ratio of what? 2:7. Very easy, right? 9 parts. So each part is 100. So 2 parts will be 200. So total copper that we have from both the alloys is 600 kgs and 200 kgs. Now, how much is total aluminum? Aluminum is coming only from first alloy. 60%. 60% of what? 1500, which is 900. And zinc. Zinc is coming only from second one. 7 parts out of this 900, which is 700. Now do the ratio. This is 800, 900, 700. So 8:9:7. Done. That's what I want. You got the ratio. 8:9 of 2:7 in a ratio of 5:3. Remember, this mixture ratio is 5:3. Then I get a final mixture of copper, aluminum, zinc, where the ratio is going to be 8:9:7. So if there are 8 parts of copper, there will be 9 parts of aluminum, and there will be 7 parts of zinc. Now going by this, what is he asking? Quantity of aluminum is what percentage more or less than the quantity of copper in the final alloy. This is my final alloy. So aluminum is how much more or less than copper? See, 9 parts of aluminum, 8 parts of, don't worry about total quantity now. That's not required. Total quantity is 2400 kgs. No, don't do all that drama. Just play with ratio. How much is aluminum? 9 parts. What is copper? 8 parts. So aluminum is how many parts more? 1 part more than 8 parts into 100. 12.5 is your answer. 12.5% is your answer. Option 5. Now for you to follow this, you should know X is, this is a very important concept of percentage. X is what percentage more or less than Y. X is what percentage more or less than Y. How do you calculate this? X difference Y by Y into 100. Very, very important concept. Basics of percentages. I hope all of you know this. X is what percentage of Y is one thing. X is what percentage more or less than Y is the other thing. So X is what percentage more or less than Y. You take the difference of X and Y, divide by Y. Comparison should be with Y. So aluminum is what percentage more or less than copper. Aluminum is what percentage more or less than copper. Aluminum is 1 part more than copper. 9 parts and 8 parts. So 9 difference 8 is 1. Then copper. Then Y here is then copper, right? What percentage more or less than copper? Copper is how much? 8 parts. So 1 by 8. If you take 1 by 9, you get a different answer. 1 by 9 means copper is what percentage more or less than aluminum. But the actual question is aluminum is what percentage more or less than copper. So 1 part out of 8 parts into 100. 1 out of 8 is 12.5%. This again is known to us, right? We know that the fraction 1 by 8 is equivalent to 12.5%. So your answer should be 12.5%, option 5. Please do not go by the length of explanation, the number of steps that you put on paper and whatever writing there. It is to explain it to you in detail, but half of this has to be avoided. Okay, so 12.5, option 5 is the final answer, and I think that's about it. Do we have anything else? I guess I have one more question. Should we take one more? Okay, let's try this. The last question for the session today. Quick. Interesting one again. Let's solve this. A container contains a mixture of milk and water in which water is 24%. So obviously milk is 76%. This is 24% he says. So remaining is milk only, right? 76% milk, 24% water, because total has to be 100%. Done. So we know the ratio. 50% of the mixture is taken out in which water is 78 liter less than milk. Find the remaining quantity of milk in that container. Now this is interesting. We have a mixture where milk and water are in what ratio? 76% milk, 24% water. Yeah. You take half of this quantity. 50% means half only, right? 50% of this mixture. So you take half of this quantity. From this you take half of the quantity. And in that half of the quantity you find that water is 78 liters less than milk. See, obviously water is always less than milk only. I mean, in this case, since water is 24%, milk is 76%, it is always going to be less than milk. Water is always going to be less than milk. But in this half quantity itself, you found that water was 78 liters less than milk. See, try to understand in terms of percentages, you know, what is the difference of milk and water? Milk minus water, 76% minus 24%, which is equal to what? 52%. In this total mixture, in 100% mixture, if I take quantities of milk and water, milk is 76% of total quantity, water is 24% of total quantity, difference is 52%. If I take half of the mixture, 50% of the mixture, what will be the difference? Same thing applies, it will be half, 26%. In half of the mixture, what will be the quantity of milk? Only half of 76%, which is what? 38%. What will be the quantity of water? 12% only. See, in 100%, 24% water. In 50%, only 12% water. In 50%, only 38% milk. The difference is what? 26%. So he says when I took 50% of mixture, it had 78 liter less water than milk. See, this difference is indicating less only, right? Water is how much less than milk? 26%. But this 26% now can be equated to 78 liters. Because this half mixture had 78 liters lesser water. I know that the water is 26% less, but that 26% corresponds to 58%. 26% corresponds to 78 liters. What is he asking us to find out? Find the remaining quantity of milk in that container. See, if half of the quantity is removed, another half is remaining. What is remaining? Another half is remaining. And in this half, how much will be milk? See, if 38% of milk is removed, remaining is another 38%, right? Out of 76%, 38% is removed. So what is the balance? Remaining another 38%. Same with water also. How much water is remaining? 12%. Out of 24, 12 was removed. In that removed thing, we found 78 is the difference. He's asking us to find the remaining quantity of milk in that container. Remaining quantity of milk is going to be only 38%. Simple. If 26% is equal to 78 liters, 38% is equal to what? Cross multiply and we'll get the answer. This is the equation that you have to solve. Just cross multiply and we'll get the answer. He says 26% is equivalent to 78 liters. So 38% should be equivalent to what? This is into 3. 26 into 3, 78. So 38 into 3, 90 plus 24, 114. Option E will be the answer. This question mark is going to be 38 into 78 by 26. Goes 3 times. 38 3s is 114. Option E is the answer. If you understand overall, there was 100% total. In this, 76% is milk, 24% is water. I'm just explaining it to you in terms of a flow chart, right? Half of the quantity. So this is the actual breakup from 38%, let me say, and this is 38%. Because you took half of mixture, right? So that half will have 38% milk. Remaining will be 38% milk. Again, the mixture that you removed will have 12% water. Balance water will be 12%. That's it. Now what is given here? The difference 78 liter. The 78 is the difference of 38 and 12. The difference, which is 26%, is equal to 78 liters. He's asking this is equal to what? So if 26% is 78 liters, sorry, not percentage, 26% is equal to 78 liters, 38% equal to what? That's what we have done here. So this is the agenda. This is the whole concept. 100% was there, in which 76% is milk, 24% water. divided into 2 halves, this also divided into 2 halves. The difference of this gave us 78. This is equal to what? Remaining milk is what? Suppose this says remaining water is how much? I'll do simply one thing. 26% is 78 liters. 12% is equal to what? 36 liters into 3. So option E, 114 liters is the final answer to this final question from this very interesting topic of alligations and mixtures. I know if you are watching this for the first time, or if you are dealing with alligations and mixtures for the first time, you may be a little taken aback. Boss, complex hai, tough hai and all that. But trust me, a very simple topic and very interesting. The whole alligation technique can be used in not just in case of mixtures, but you have used alligation technique in simple and compound interest. We have used alligation technique in other questions as well. Right? Some examples are available. You can just check the YouTube channel that we have. The point is a very important concept and easy to follow. Solve some 10 or 15 questions. You'll master this whole topic, and then be prepared with it. You never know. You may not get any question at all in the exam, IBPS PU exam, or you may get 5 questions. It's up to you whether you want to take this risk or not. Not preparing on this topic may lose you up to 5 marks, which is huge in my view. And the concept is simple enough for you to take any chances. So please go through the videos that we have on alligations and mixtures, basic videos, other additional videos that we have, and master this. Okay, thank you all for joining us. I think I have overshot by 15 minutes at least. Sorry about that. Try and keep it to 1 hour next session onwards. But yeah, it was good interacting with you guys. Keep joining us for these live classes and keep watching the videos. All you have to do is subscribe to the channel and you'll get all the updates that we have for you. And remember, there are only 3 shortcuts to score more in this exam. Number 1, practice. Number 2, practice. Number 3 also is practice. So it's up to you. Keep practicing and do take very good care of yourselves. I'll see you all in the next session. Bye.